Hey, this is Kat Martinez. It is February 9th of 2020, and I have in front of you my power supply. It is a power supply that I designed hoping to be at 15 volts, running out of these output jacks. There's a couple nice safety features that are designed in here. If you notice, it's recessed for the actual contact point in here. You can have it completely closed for safety. Or, say for example, let's see if I get that to focus in a little bit better. You want to ground out, you actually have a way of pinning in your different leads and holding it in place, as well as an output jack that will fit most multimeter scopes that have this particular jack attached to it. Alrighty then, let's see if we can get this thing to go back into focus. Haha, there it is. So basically what we have here, I'm going to go ahead and put my positive lead in. As you can see, the power is off currently. I'm going to go ahead and flip my switch. Make sure I get a nice contact in there. You can see it's 14.9, 14.8, 14.9. These are 100% recycled parts, so some of the metals just need a little bit of cleaning up, and I think what that 0.2 difference might be is that. But you can see it's successfully 14.8, and that is voltage DC. Now I'm going to go ahead and switch this over to AC. At least 200, make sure I don't mess with it too much. But ultimately, so right now we got our negative lead attached only. There's nothing touching positive. It's picking up some air resistance, but going into the volt right here, it's at 0 because it's not reading AC waveform coming out of the wall outlet at 120, which is what we have coming in here. It's been converted through a bridge rectifier right here using diodes. So what's going on, we'll go ahead and switch this back over to DC again in the 200 range. 20 would suffice, but at the same time I don't really want to chance it just in case something happens. Alright, so basically we've got 116 volts measured in from this particular cord that's coming from just your normal wall outlet. It goes into this transformer, which is stepping it down. And then it takes it down to a 110 volt, which is coming out here. And you got the two different leads that are leading into our rectifier right there. I'm going to go ahead and grab my little pointer here. Let's see if it's actually on, because I do want to take some measurements. It is on, so we need to be extra careful with the circuit. But when we're looking inside of here, I'm going to get it focused in. I'm going to try to hold really still so you can see what I'm doing. You got the transformer, it's taken in right here. Goes through, comes out here. We have it fused up top just in case anything happens. Here is your bridge rectifier. Now this capacitor here is a smoothing capacitor, so that the little bit of current that's coming through that is still in AC form is reduced down so much that it would not really be picked up on an oscilloscope. I've got a pretty cheap multimeter here, my fancy ones at school. But basically what's going on is you are not going to pick up as much information on one of these cheaper ones. It's not really going to be able to be measured. You'd want an oscilloscope, but the goal in this particular project is to have less than 1% ripple, which would be barely noticeable unless you had everything turned up quite a bit. So the switch that runs it over here is a rocker style switch, and it goes between live, which it is right now. That's actually contact with me touching there. To 0. Back on that is put in for safety. And let's go back inside of here. Now the circuit board and everything is held down by super glue. It's a silicone based super glue so that it's insulating. And then if you look at these things way back here on the very bottom side, I'm not going to flip it down or upside down because it is actually on right now. There's a grounding plate as well, so everything is, like this point here is coming out to ground. There's a spot here it's coming out to ground. I kept all the wire colors according as well. Lots of fun little features. It's actually been a pretty neat project. So let's look at some numbers and see if I can hold still here enough so you can see it. Test it. Is it on? Oh yeah, it's on. So when we come out of the transformer, you've got your negative point right here, which when you touch it, it reads 0. That you know effectively is being grounded, so you're checking out that part there, and that's part of the bridge rectifier. Now when it's coming in right here, you got a bad connection. Let me get a better grip there. 5, pushing forward, volts. And then right here, 5, right? Now watch this, this is kind of cool. Once it gets past these 2 diodes, and they're a little part of the configuration, it jumps up to 14.8, which is the voltage that we're actually putting out at the final output stage. Now the capacitor, again, is just a smoothing. And then once we're ready to take our measurements, or we want to put something out that needs, you know, pretty much 15 volts, or you want to charge like a DC battery, which is actually the intention on this one, I can hook up some bigger wires to it. Basically, you have the ability to do that over a period of time now. So, again, let's see if I get a better contact in there. You can see how it moves around. I gotta get the metal clean. So, cool part. All the parts here came out of an old 80s receiver. Even these little jacks right here, which I absolutely love the design of. They're meant to hold speaker wire, and they have the audio for often like big speaker sound systems and stuff like that. The board was a board that I had in a kit from a long time ago, and I wound up reusing it. I had this built up differently first, and I wound up rebuilding it because my first design was not as good as this, and I had a diode that had gone bad. The fuse here is just kind of a safety precaution. If anything really goes crazy in the circuit here, it stops before it blows up the whole circuit. And then make sure you're using heavy duty plugs. You're not messing around with little wires. You want them to be enough of a gauge to carry the currents that's going through there and voltage and whatnot, so that they don't get too hot or burn out, you know, to make sure you're matching up all your specs. And that is my project.